This video will show you a really powerful part of FFE. It's showing you what actually will happen to your formulation, to all the components in the formulation as it attempts to go through the skin. It's a complicated model because there is so much happening, but you'll see there are plenty of ways to make sense of it, so it's not as scary as it first seems. I've chosen a totally arbitrary formulation just for demo purposes. I've got a large molecule, polydecene, a small molecule, glycerin, medium one, mineral oil, and DMI. I've got 10 microns of it sitting on the skin, and my stratum corneum is 15 microns thick. I've got a total of half a micron of active in there because it's present as 5%. I'm going to simulate for 5 hours. The ingredients, so there's 5% of the active in the formulation, then each of the ingredients is there in the same percent, 22.6%. And what I'll do now is press the calculate button and we'll see what happens. All sorts of things are happening on the screen, and the calculations are very complex because many things are happening at the same time. The software has to take that into account, and we've done 3 hours of simulation now. 4 hours, you've got another hour to go, 4.5, and now the calculation is finished. So let's see what we've got. By definition, the AFG, the active formulation gap, was set as 1 relative to what it was at the start, same with the SFG. And we started off with 10 microns on the surface, and therefore none in the skin and none pass through. Over time, the solubility of the active actually got better for a short while, and then got worse. Now, why is that? Because one of the components, glycerin, which is not very compatible to the active, diffuses very quickly through the skin, and that's why you gain and match with the active, and therefore a decrease of the AFG. With the SFG, things are worse. As time goes on, the compatibility of the whole formulation with the skin decreases, and the SFG goes up quite a large amount. Now, why is that? Let's look at the graph. We started off with the same amount of each of the 4 ingredients. The glycerin fell off very quickly because it's a small molecule. The DMI was the next smallest, goes off very quickly. And so the percentage in the formulation on the top of the polydecene goes up very high, and at the end it was 57% of the 3.3 microns which remained on the skin. The mineral oil is relatively medium sized and so hasn't changed much over the time. But it means at the end, on your skin, you've got 57.5% of the polydecene, none of the glycerin, which went quickly, none of the DMI, which went, and you've got 27% of the mineral oil. Now you can start to see the power of this, because now you're seeing how your active is going to, and your formulation are going to interact with the skin, and how quickly or slowly they'll go through. And of course, when you model these with different size molecules, for example, with a smaller version, a smaller equivalent of the polydecene, then things might be different. Let's look at the other graphs. This graph is showing you the concentration through the skin. And this first curve here, the first time step, shows you starting off at 100% by definition, and then falling off through the skin to nothing at the other side. As time goes on, so as the color goes from the bluish right through to the red, so the red is the last time step, you've got different gradient. At the end, because the solubility of the formulation is much lower, you've got less in the surface of the skin, and therefore you've got less driving force. So the rate of diffusion of everything is much lower. This is showing the amount in the stratum corneum. It increases at start because stuff is diffusing in, and it's not too incompatible, but then as the compatibility decreases, it falls down. And this is showing the amount permeated through. And this is the classic extrapolation, which for simple skin delivery is a straight line, matches that curve for the breakthrough time. But for this complex thing, it's no longer relevant. Now, this particular 5 hours has been relatively successful. We start off with half a micron equivalent of the active, and after this time, 0.448 of that has gone through, and we're left with only a small amount of active on the surface. So maybe this formulation wasn't too bad, but if you do some simple experimenting, you can get that same amount through much faster using better ingredients. I hope that's given you a flavor for this model. There are many more options to be played with, but I think